A massive stone face stares out from the desert, defying every explanation modern science can offer. This video reveals 20 monumental statues whose construction is still an unsolved mystery. By the end, you will understand the profound gaps in our knowledge of ancient engineering and the incredible people who built them. How did civilizations move 100-ton stones without wheels? And why did they carve giants into mountainsides? What does our inability to solve these puzzles say about our own relationship with the past? That silent guardian of the Giza Plateau holds its secrets close. While mainstream archaeology places its creation during the reign of Pharaoh Khafre around 2500 BC, a compelling alternative theory challenges this timeline. Geologist Robert Schoch studied the weathering on the Sphinx's body, noting deep vertical fissures that he argues were caused by prolonged, heavy rainfall. This kind of erosion points to a much wetter climate in Egypt's distant past, potentially pushing the statue's origin back thousands of years earlier. This single statue, carved from a single limestone ridge weighing an estimated 20,000 tons, now sits at the center of a profound debate. Was it the work of a known pharaoh, or evidence of a forgotten civilization lost to time? The construction itself is a marvel that defies simple explanation. How did ancient artisans achieve such perfect symmetry and intricate detail, carving the massive paws and regal headdress with what we assume were simple copper tools? The sheer logistics of quarrying and shaping that much stone without the wheel or advanced machinery suggests a level of organizational skill and technical knowledge that we are still struggling to comprehend. The Sphinx's weathered surface does not just tell a story of artistic triumph, but potentially a hidden history of Earth's changing climate. It stands as a monumental question mark in the desert, a reminder that some of our oldest mysteries are still waiting for answers. This leads us to another giant whose very purpose is equally debated. Their colossal stone faces gaze inland across the grassy slopes, a silent army with their backs to the vast ocean. Easter Island, one of the most isolated places on Earth, is home to the nearly 900 Moai, and their creation is a staggering feat of engineering. How did the Rapa Nui people move these multi-ton giants from the quarry at Rono-Roroku to their distant ceremonial platforms, some as far as 11 miles away across rugged terrain? Modern experiments have tried to solve this puzzle by literally making the statues walk. Teams of researchers using heavy ropes have shown it is possible to rock a replica Moai side to side, creating a shuffling forward motion. But proving a method works in a controlled test is different from confirming it was the method used centuries ago, especially given the island's limited timber resources. The theory of wooden sledges gliding over log rails faces the same ecological question. Such an effort would have consumed enormous amounts of the island's precious trees. This leads to a deeper mystery about the society itself. Did the immense cultural drive to create and erect these monoliths ultimately contribute to an ecological hardship? Or does the very survival of the people and their traditions suggest a more complex story of adaptation? Archaeologists like Jo Ann van Tilburg remind us that these were not just stones, but sacred repositories of ancestral spirit. The real wonder lies in the collective will it took to carve, transport, and raise them, a mobilization of human effort that continues to baffle us. This profound mystery of moving massive stone gives way to an even greater challenge of creation, one carved directly into a living mountain. Its immense bronze form was said to tower over the harbor entrance, a god of the sun cast from the very weapons of a defeated army. The Colossus of Rhodes was one of the legendary Seven Wonders, a statue of the god Helios that reached over 30 meters into the sky. Forged from the bronze of abandoned siege engines, its construction was a symbolic victory made physical. Yet the methods used to build this giant remain one of history's great architectural puzzles. How do you make a figure of that scale stand, let alone straddle a busy waterway using the technology of 280 B.C.? Contemporary accounts are frustratingly sparse, leaving modern engineers to debate the possibilities. Some propose a sophisticated internal skeleton of iron bars, a framework that would have been revolutionary for its time. Others argue for a more traditional approach, with the statue being assembled in sections against an earthen ramp for external support, its hollow form filled with stones for stability. The truth is, we have no physical evidence, no sunken ruins in the harbor to study. Its legacy is built entirely on fragments of text from writers like Pliny the Elder, who recorded its existence but not the secrets of its creation. The statue's story is also a lesson in fragility, standing for only 56 years before a powerful earthquake brought it down. This rapid collapse raises profound questions about ancient understanding of seismic forces and structural integrity. Did the builders push their materials to a breaking point they could not foresee? The Colossus, for all its grandeur, teaches us about the ambition and the limits of ancient engineering, a marvel that shone brilliantly but all too briefly. This search for stability leads us to a monument that seems to defy gravity itself, carved not from metal but from a single, impossible piece of stone. The sheer cliffs of Sichuan province in China hold a serene giant, a monumental act of faith carved directly into the living rock. The Leshan giant Buddha is the largest stone Buddha statue in the world, a 71-meter-tall figure gazing peacefully over the confluence of three powerful rivers. Its construction was a project of breathtaking patience, begun in the early 8th century and taking 90 years to complete. The spiritual motivation was profound, a monk's vision to calm the treacherous waters that plagued local boatmen and honor the teachings of Buddhism. But this was not just a spiritual endeavor, it was a masterpiece of long-term engineering. The builders faced an immense challenge: how to protect their creation from the very elements it was meant to pacify. Their ingenious solution was a hidden network of drainage channels carved directly into the statue's body and concealed within the coiled hair. These channels, still functional today, divert rainwater away from the stone, preventing the erosion that could have destroyed the statue centuries ago. The construction itself required the precise removal of vast amounts of rock, shaping the cliff face into the graceful folds of robes and the gentle features of a face. Researchers are still puzzled by the logistical planning. How did the teams of monks and artisans coordinate this multi-generational project without modern blueprints or scaffolding? There is no archaeological evidence for the massive wooden structures we would expect, suggesting they may have used the natural contours of the cliff itself as their platform, carving from the top down in a carefully orchestrated descent. The Leshan Buddha stands as a perfect fusion of environmental engineering and deep faith, a project where managing water flow was as important as capturing a spiritual expression in stone. This blend of colossal scale and intricate, hidden systems finds a fascinating parallel across the world, where another ancient culture carved its own giants from the very earth itself. Deep within the humid jungles of Mexico, massive stone heads emerge from the earth, their stern faces a silent challenge to history. These are the Olmec colossal heads, 17 known sculptures carved from single blocks of basalt, some weighing as much as 20 tons. The first question is one of pure logistics. The basalt came from the Tuxtla Mountains, quarried from volcanic rock and transported over 50 miles through swamps and dense rainforest to the Olmec heartland. Without the wheel, without pack animals, how was this possible? The leading theory suggests a monumental effort of human strength, using rollers and ropes to move the stones to rivers, where they could be floated on rafts for the final leg of the journey. Yet this explanation only deepens the mystery of the society that commanded such effort. Who were these individuals immortalized in stone with their distinctive helmets and expressive features? Were they powerful rulers, revered ball players, or deified ancestors? The sheer consistency in style across centuries points to a rigid, sophisticated artistic tradition, a cultural blueprint passed down through generations. But the technological puzzle is just as compelling. Basalt is an incredibly hard stone, yet the Olmec artisans carved intricate details, from the subtle lines of the lips to the elaborate headgear, using what we believe were simple stone tools. Researchers have attempted to replicate this work with similar materials, and the process is agonizingly slow, demanding not just immense skill but an almost superhuman patience. The existence of these heads tells us the Olmec were not a simple society, but a complex civilization with the organizational power to coordinate massive labor projects and the artistic vision to create enduring symbols of authority. This mastery of human form in stone finds a strange and powerful echo in a different part of the world, where another ancient culture blended human and animal into a single mythical guardian. Serenity radiates from the great Buddha of Kamakura, a monumental bronze figure seated peacefully in the open air. Cast in the 13th century, this statue stands over 13 meters tall, a testament to a forgotten technological prowess. Unlike many colossal statues assembled from stone blocks, this Buddha was cast in bronze as a hollow structure, using a sophisticated version of the lost wax method. But the true mystery is not just how it was made, but how it has survived for more than 750 years, enduring countless earthquakes and powerful typhoons that would have shattered a lesser creation. The casting process itself was a marvel of pre-industrial planning. Artisans built the statue in multiple large sections, which were then joined together so seamlessly that the seams are virtually invisible to the naked eye. This technique provided the flexibility needed to sway and absorb seismic shocks without fracturing. Yet the precise formula for the bronze alloy remains a subject of intense study. Temple records give clues, but modern analysis suggests the metal contains a unique blend of copper, tin, and lead that gives it exceptional strength and a beautiful, enduring patina. Even more puzzling is the furnace technology required. To melt such vast quantities of metal at once would have required a furnace of immense scale and heat, a feat of engineering that seems to push the boundaries of what was possible in the 13th century. How did they achieve such consistent, high-temperature pours without modern refractory materials? The great Buddha is more than a religious icon. It is a perfect fusion of artistic vision and material science, a project where deep cultural devotion directly fueled a quiet technological revolution. This drive to create enduring, sacred figures from metal finds a fascinating and much older parallel in the ancient Near East, where a legendary creature was fashioned not from bronze but from gleaming gold. Guardian figures of immense power stood at the gates of Assyrian palaces, their forms a fusion of human intelligence, avian divinity, and bovine strength. These Lamassu were carved from single, colossal blocks of alabaster or limestone, each one a statement of imperial authority. Their most ingenious feature is a trick of perception, a fifth leg carefully sculpted to make the creature appear standing firm when viewed from the front, yet striding forward when seen from the side. This was more than artistic flair. It was a deliberate message to all who approached that the empire was both eternally stable and perpetually in motion. The initial challenge of quarrying and moving these multi-ton blocks was monumental, likely involving teams of workers and sledges across great distances. Yet the greater mystery lies in the final carving. How did artisans achieve such precise symmetry and deep, intricate relief work on the wings and beards using only hand tools? Scholars like Irene J. Winter have emphasized the symbolic power these figures held, representing protective deities that made the king's palace a cosmic center. But the physical process of translating that symbolism into stone with such flawless execution remains elusive. The creation of a single Lamassu was an act of empire building itself, a demonstration of control over resources, labor, and artistic tradition. This seamless blend of monumental architecture and symbolic art finds a breathtaking parallel in another part of the ancient world, where an entire temple was carved not from blocks but from the top of a mountain down. On a hilltop in Karnataka, a monolithic giant stands in serene meditation, completely untouched by the world around it. The Gommateshwara Statue, carved in the 10th century, rises 17 meters from a single block of granite, its surface so perfectly smooth it seems to have been poured rather than carved. This is one of the world's largest freestanding monolithic statues, a representation of a Jain spiritual figure who achieved enlightenment after standing in silent meditation for so long that vines began to climb his legs. The sheer hardness of granite makes the achievement almost unbelievable. How did artisans, using only hand tools, achieve such flawless proportions and a mirror-like polish across this immense form without causing a single fracture? The physical discipline required to create the statue seems to mirror the spiritual discipline it honors. Jain texts speak of immense devotion fueling the project, but the engineering specifics are lost. The most daunting challenge would have been the final stage, raising the multi-ton statue to its upright position on the platform. Theories suggest the use of earthen ramps and complex rope and pulley systems, yet no archaeological evidence confirms the exact method. This flawless creation, born from deep faith, stands in stark contrast to the next statue on our list, a monument not to spiritual peace but to absolute imperial power. Rising over 30 meters in the heart of Rome, the column of Marcus Aurelius is a stone scroll spiraling towards the sky. Its surface is a continuous narrative, a detailed marble frieze winding upwards to recount the emperor's military campaigns against northern tribes. Each level is a chapter carved from massive marble drums, stacked with such precision that the scenes flow seamlessly from one drum to the next. The primary engineering challenge was twofold: lifting these colossal stone cylinders into place and then ensuring the carved story remained perfectly aligned. How did Roman engineers manage such flawless vertical alignment without modern surveying tools? The leading theory involves complex systems of pulleys and cranes powered by human labor, but this does not explain the artistic coordination. Teams of sculptors must have worked on the column after it was erected, carving the intricate battle scenes while suspended on towering wooden scaffolding. This in-situ carving process required immense foresight, as a single deep miscalculation could have cracked the entire marble drum. Classical scholars like John Shade point to the column's complex iconography, a deliberate propaganda piece designed to showcase Roman order triumphing over chaos. Yet the logistics remain baffling. How did the master sculptor coordinate multiple teams working on different sections simultaneously, ensuring the stylistic consistency of thousands of figures across the entire height? There were no blueprints as we know them, only wax models or painted guides that have long since vanished. The column stands not just as a monument to victory, but as a testament to a lost system of project management and artistic communication, a symphony in stone whose conductors remain anonymous. This Roman mastery of telling a story on a colossal scale finds a dramatic contrast in a monument that is not a narrative, but a single, silent, and divine face emerging from a cliff. A modern king's face stares defiantly across the Danube River, a monumental sculpture carved directly into the cliff face on the Romanian bank. The Decebalus statue is the largest rock sculpture in Europe, a tribute to the last king of ancient Dacia, and it was completed in just under 10 years, finishing in 2004. This modern project, funded by a wealthy historian, provides a unique window into the immense challenges of rock carving, precisely because it used the very tools ancient cultures lacked. Teams of workers dangled from ropes, using power drills and controlled explosives to remove over 300,000 cubic feet of rock. This was a dangerous, precise operation with every advantage of modern engineering. And it still took a decade. This forces a profound question. How did ancient societies with only hand tools, fire, and water achieve similar or even greater feats? The modern effort reveals the sheer physical difficulty of working at such a scale, the constant risk of catastrophic fracture, and the monumental organizational effort required just to support the artisans. The project's lead sculptor noted that even with their technology, the final detailing of the eyes and crown required the patience and skill of a master stone carver, a reminder that ancient genius was as much about artistry as brute force. This modern homage to an ancient king makes the accomplishments of his contemporaries even more baffling. It points us toward a pre-Columbian mystery, a giant whose construction remains completely unexplained. Standing over 4.5 meters tall, the Atlantean figures of Colossal are giants of basalt, their stoic faces and detailed armor defying the centuries. These colossal Toltec warriors served as pillars for a grand temple roof, a structural role that makes their precision carving even more critical. Each figure is a single block of stone, quarried from a site many miles away and transported without the wheel or pack animals. The sheer weight of the stone, combined with the intricate carvings of headdresses and weaponry, presents a dual mystery of logistics and artistry. How did they carve such hard rock with what we believe were stone tools, achieving smooth surfaces and sharp geometric patterns? The prevailing theory involves a system of levers, ropes, and earthen ramps, a monumental coordination of human labor. Yet, the figures have withstood the test of time in a region known for seismic activity. Their enduring stability suggests the Toltec builders possessed a deep, intuitive understanding of weight distribution and structural integrity, knowledge that was likely passed down through generations but never written in a text we can decipher. This mastery of stone in a volatile landscape finds a haunting parallel in a very different part of the world, where another civilization carved its devotion directly into a cliff face, only to have its greatest work face a threat its builders could never have imagined. For over 1,500 years, two serene giants watched over the Bamiyan Valley, their niches carved so high into the sandstone cliffs they seemed to touch the sky. The Buddhas of Bamiyan, standing 55 and 38 meters tall, were not solid stone, but complex structures of carved rock core reinforced with a unique mixture of mud, straw, and plaster. This hybrid construction is the central mystery. How did 6th century artisans create such massive, stable forms in a sheer cliff face, especially in a region of extreme temperature shifts and seismic activity? The wooden pegs and iron clamps found in the remnants suggest a sophisticated understanding of how to bind the stone and plaster shell together, allowing the statues to flex and breathe with the mountain. Yet the process of carving the initial niches themselves defies easy explanation. Researchers like Deborah Klimberg-Salter have highlighted their role as monumental centers of Silk Road pilgrimage, but the practical engineering is less clear. Teams would have worked from precarious wooden scaffolding, carving downwards from the top in a dangerous, multi-generational project. The final, smooth finish was achieved with a plaster layer that could be molded and painted, creating flowing robes and serene expressions that glowed in the Afghan sun. The tragic destruction of these figures in 2001 was a profound loss to world heritage, but the rubble itself has become an archive. Studying the fragments reveals clues about the precise mortar recipes and structural techniques that allowed them to endure for so many centuries. Their absence speaks volumes about the ingenuity of Silk Road engineers, who mastered their environment to create wonders of both art and stability. This legacy of serene devotion carved into a mountainside finds a powerful echo far to the south, in the ancient capital of Sri Lanka. Its graceful form seems to emerge naturally from the living granite, a standing Buddha of serene perfection. The Avukana statue in Sri Lanka, carved in the 5th century, is a masterclass in precision and devotion. Unlike many colossal figures assembled from blocks, this 12-meter giant was sculpted directly from a single granite outcrop. The true marvel lies in its perfect proportions, a feat believed to have been guided by a complex system of anatomical measurements. Artisans likely used a specific set of ratios where the width of the face determined the length of the nose, and the span of the outstretched hand defined the overall height. This spiritual geometry ensured the statue was not just a representation, but a perfect embodiment of enlightenment. Yet, the physical execution is just as baffling. Granite is one of the hardest stones, yet the surface of the statue is flawlessly smooth, with the delicate folds of the robe flowing as if made of silk. How did they achieve this mirror-like finish without modern diamond-tipped tools or industrial abrasives? The prevailing theory suggests endless hours of polishing with sand and water, a labor of love that would have consumed generations. This statue stands as a testament to a profound partnership, where deep spiritual conviction met an almost supernatural level of artisan skill. Such devotion to creating a perfect guardian finds a powerful echo in the myths of ancient Greece, where a giant of bronze was said to come alive. A regal marble lion rests upon the plains of Chaeronea, a silent guardian for a sacred purpose. This immense statue was erected in the 4th century B.C. to honor the elite Theban soldiers who fell in a pivotal battle, a unit known as the Sacred Band. Its powerful form is carved from multiple massive marble blocks, but its true secret lies within. The lion was hollow, a carefully constructed chamber designed to serve as the final resting place for the remains of the soldiers. This dual function as both monument and tomb presents a profound engineering puzzle. How did ancient Greek artisans construct a hollow statue of that scale while ensuring it possessed the structural integrity to stand for centuries? The techniques for shaping, fitting, and sealing the marble blocks are lost to us, because the statue was found in fragments by archaeologists and painstakingly reconstructed in the early 20th century. The original builders achieved seams so precise they needed no mortar, a testament to a sophisticated understanding of stonework and weight distribution. This was not just a sculpture, it was architecture on a deeply personal and ceremonial scale. Its existence speaks to a culture that honored its fallen with immense public works, blending artistic beauty with solemn duty. The logistical choices, from quarrying the marble to assembling the hollow core, reveal a society that mastered both the physical and spiritual dimensions of memory. This monumental lion, a symbol of courage and loss, guides our focus south to the land of the pharaohs, where another ruler's likeness was carved with a similar fusion of divine power and human remembrance. Two silent giants have kept watch over the Theban plain for more than 3,000 years. The Colossi of Memnon are twin statues of Pharaoh Amenhotep III, each carved from a single block of quartzite sandstone weighing an estimated 700 tons. They once guarded the entrance to the pharaoh's vast mortuary temple, a complex that was largely lost to the flooding of the Nile. While ancient inscriptions boast of moving these monoliths from quarries hundreds of miles away, the practical reality of that journey remains a core mystery. We know the stones were floated on barges down the Nile during the annual flood, a feat of timing and coordination in itself. But the overland transport from the riverbank to their final positions is the true puzzle. How do you move a stone heavier than a fully loaded jumbo jet without cracking it, using only ropes, sledges, and human muscle? Egyptologists like Auric Saurusian, who leads the ongoing restoration of the site, suggest a carefully prepared pathway, constantly lubricated with water or mud to reduce friction. Yet the sheer scale of the operation, the precise logistics of turning and positioning the statues, points to a level of project management that rivals any modern construction. The statues themselves bear the marks of their long history, including damage from an ancient earthquake and later restoration in the Roman era. One colossus was even famous in antiquity for emitting a musical sound at dawn, a phenomenon later scholars attributed to rising temperatures and evaporating moisture within its cracked stone. These giants are more than royal portraits. They are monuments to the invisible army of engineers and laborers whose names are lost, but whose legacy of moving the immovable still defines the Egyptian landscape. This mastery of stone on a divine scale finds a breathtaking parallel in the jungles of Southeast Asia, where an entire city was built to mirror the cosmos. Hundreds of serene stone faces gaze down from a forest of towers, their enigmatic smiles a silent language of cosmic power. The Bayon Temple at the heart of Angkor Thom is a masterpiece of the Khmer Empire, a sprawling complex where 54 towers are each carved with 4 of these immense visages, looking toward the cardinal directions. This creates a staggering 216 faces, a stone audience witnessing the world from every possible angle. The prevailing belief is that these are the face of the Bodhisattva Avalokiteshvara, bearing the features of the great King Jayavarman VII himself, merging the ruler with the divine in an act of architectural symbolism. Yet the practical execution of this vision is what truly baffles researchers. How did teams of artisans achieve such uniformity across hundreds of sandstone blocks, ensuring every smile, every lowered eyelid was carved with the same serene expression? The stone itself was quarried from Mount Kulin over 30 miles away, transported along canals, and then lifted into position. But the carving likely happened in situ after the towers were built. This means sculptors worked from precarious scaffolding, replicating a master pattern with astonishing consistency. There were no power tools, no digital templates, only skilled eyes and hands guided by a shared cultural blueprint. The organizational structure needed to coordinate this effort is a mystery in itself. It suggests a rigid hierarchy of master sculptors and apprentices, a system of artistic quality control that operated on a colossal scale. The harmony of the Bayon is not just spiritual, it is a testament to a lost system of project management, a symphony of stone whose conductor remains a smiling, silent king. This profound unity of cosmic design and imperial ambition finds a powerful, yet starkly different, expression in the highlands of Ethiopia. Towering stone needles pierce the Ethiopian sky, silent memorials to a forgotten kingdom's power. The Stelae of Axum are not just markers, they are feats of engineering carved from single, massive blocks of granite, with the largest standing over 30 meters tall and weighing an estimated 500 tons. Each one was a funerary monument for the Axumite elite, a civilization that thrived for centuries as a major trading empire. The journey of these monoliths began at a quarry several kilometers away, where workers had to extract these perfect, multi-story tall stones without causing a single crack. The surfaces are intricately carved, featuring false doors and symbolic patterns that mimic the multi-story buildings of the Axumites themselves. How did they achieve such precise work on one of the hardest stones on Earth, using what we presume were simple iron tools? The transportation is an even greater puzzle, with no evidence of the wheel being used, and in a landscape of rolling hills, moving a 500-ton block seems impossible. The leading theory involves a system of ropes, sledges, and a carefully prepared trackway, possibly lubricated with mud to reduce friction. Some researchers suggest they may have used a rocking motion, slowly walking the stelae to their destination over a period of months. The final act of raising them is its own mystery. Did they use earthen ramps, digging a pit and gradually pulling the stone upright as they filled the hole? Or did they employ a clever counterweight system, using the weight of the stone itself to aid in its own erection? The Stelae of Axum stand as a profound legacy of African engineering, a demonstration of a society that mastered its environment through collective will and sophisticated, though unrecorded, techniques. This mastery of stone in service of memory finds a powerful, though much colder, echo in the myths of the far north, where a giant was said to be carved not from rock but from the landscape itself. Runes and beasts intertwine on a weathered granite surface in the Danish town of Jelling. This is not a single statue in the traditional sense, but a monumental runestone from the 10th century, its surface dominated by a large, powerful figure of Christ, not on a cross, but entangled with what appear to be pagan vine and beast motifs. This intricate fusion is the key to its mystery. King Harald Bluetooth erected this stone to commemorate his parents, and more importantly, to proclaim his conversion of the Danes to Christianity. The artwork itself is a perfect symbol of that cultural shift, deliberately blending the old world with the new to make the message resonate. Yet, the practical creation of this masterpiece is a puzzle. How did artisans incise such deep, clean lines and complex relief into this incredibly hard granite using only hand tools? The specific chisels, hammers, and abrasives they employed are not documented. Scholars like Else Rosedal can interpret the profound historical significance, but the workshop techniques are lost. The precision of the runic text, which must be read perfectly to convey the king's proclamation, suggests a level of literacy and artistic planning that challenges our view of the Viking Age. This was not crude carving. It was a sophisticated act of political and religious communication set in stone. The stone's endurance speaks to the skill of its creators, a skill that allowed a king's declaration to outlast empires. This powerful symbol of a new identity carved from an old world finds a strange and modern echo in a colossal head that emerged from the American wilderness. A mountain in South Dakota is slowly transforming into a warrior on horseback, a work in progress for more than 7 decades. The Crazy Horse Memorial is a modern attempt to create the world's largest sculpture, a monument so vast that the entire Mount Rushmore complex would fit within the horse's head. The sheer scale of its ambition forces a direct comparison with the ancient statues we have explored. Here, workers use dynamite for bulk removal and sophisticated laser-guided tools for precision carving, a process documented in meticulous detail. Yet, even with these immense technological advantages, the project is measured in generations, not years. This contemporary effort throws the achievements of the past into sharp, humbling relief. It makes you wonder if a modern team with advanced machinery and engineering software faces such a prolonged and complex challenge. What does that say about the societies that carved the Sphinx or the Leshan Buddha? The memorial is more than a tribute. It is a living laboratory that highlights the profound unknowns of ancient logistics. It underscores that the true mystery is not just the physical act of carving, but the sustained cultural will, the uninterrupted flow of resources, and the generational knowledge transfer required to see such a vision to completion. This reflection on the timeless nature of monumental ambition brings our journey to its final stop, on the shores of the Mediterranean, where a colossal wonder once stood guard. Inside the great temple at Olympia sat a god on a throne, a figure of ivory and gold so immense his head nearly brushed the roof. The statue of Zeus was the work of the sculptor Phidias, a masterpiece counted among the 7 wonders of the ancient world. Its construction method, known as chryselephantine, is a term we know from descriptions, but the full craft is lost. This was not a solid casting or a stone carving, but a colossal assembly. A wooden framework served as the skeleton, onto which plates of ivory were fitted for the god's skin and gleaming gold for his robes. The challenge of this technique is staggering. How do you prevent these precious materials from cracking or warping over time in a humid Greek temple? Ivory, a living material, reacts to temperature and moisture, while heavy gold sheets could easily stress their wooden mounts. The descriptions by writers like Pausanias speak of a reservoir of olive oil kept at the statue's base, a substance thought to maintain the ivory's humidity and prevent it from splitting. This reveals an ancient understanding of material science, a proactive preservation system built into the wonder itself. Yet without a single surviving fragment, we can only speculate on the hidden joinery, the internal bracing, and the precise recipes for the adhesives that held it all together. This statue represents the pinnacle of Greek artistic innovation, not just in its divine beauty, but in its daring fusion of materials on a scale never attempted before. Its eventual loss, likely in a fire centuries later, feels like a metaphor for the fragility of this forgotten knowledge. All 20 of these statues, from the stone colossi to this golden god, are threads in a single, vast tapestry of human endeavor. They are not separate puzzles, but different expressions of the same driving force, the need to reach beyond our grasp and leave a mark that defies time itself. Their unresolved mysteries are not failures of our science, but eternal invitations to wonder at the depth of human creativity. Each of these giants, from the Sphinx to the colossal heads of Easter Island, presents its own unique riddle. Yet when we step back, a fascinating pattern emerges. Across continents and centuries, these projects shared a profound reliance on local materials, a deep spiritual or political motivation that drove generations of work, and the incredible power of collective human effort. They solved the same fundamental problems of moving and shaping stone, yet their solutions appear to have been invented independently, tailored to their specific environments and cultural beliefs. Modern science is not standing still in the face of these puzzles. Researchers now deploy ground-penetrating radar to see inside structures, use 3-dimensional laser scanning to map the most minute tool marks, and perform material analysis on stone samples to trace their exact quarry sources. These tools provide invaluable data, yet the core questions of daily practice often remain. How exactly did a master sculptor communicate a complex design to a team of 100 artisans? What specific songs or rhythms coordinated the pull of 1,000 ropes? These are the intangible elements, the human factors that leave no fossil record. The true gap in our understanding may not be the engineering itself, but the social and cultural frameworks that made such engineering possible. These societies demonstrated a resilience and creativity that we are still striving to fully comprehend. They did not see 100-ton stone as an impossibility, but as a challenge to be met with patience, ingenuity, and shared purpose. their enduring legacy asks us a reflective question. In our modern world of rapid technological advancement, have we lost something of that generational patience, that deep cultural drive to create something meant to last for millennia? These silent stone witnesses remind us that the greatest mysteries are not just about how they were built, but why their builders reached for such timeless grandeur in the first place. These silent stone witnesses from the Sphinx to Zeus remind us that our past is filled with secrets modern science has yet to fully unlock. Each mystery we have explored, from the transportation of 100-ton stones to the carving of impossibly smooth surfaces, highlights the profound and often overlooked capabilities of our ancestors. We have journeyed through debates on engineering, artistry, and symbolism, seeing how every monumental statue is a reflection of its culture's deepest values and the unique environmental challenges it faced. They are not just art, but enduring statements of human ingenuity, collective will, and spiritual belief. Let these unresolved puzzles inspire your own curiosity. Perhaps the next time you visit a local museum, you will look at ancient artifacts with a new sense of wonder, or share your own theories about these marvels in the comments below. If you enjoyed this deep dive into history's greatest architectural puzzles, subscribe for more journeys to the edges of our understanding. Remember, the greatest wonders often lie not in the answers we possess, but in the profound questions we have yet to answer. Thank you for joining this exploration.